In this next homework, which is 4.2, I don't really, it's named substitution. And substitution's very handy, but I don't really see a substitution to do on problems like this. So they want to know the antiderivative of this function. Well, so that means we should integrate 2e to the x plus 5 minus 3x to the minus 2/3. But this is just, so to me, all I see is that, okay, well, I can see a substitution now. It's trivial. So here I'll do it one way this time, and then the next problem I'll make the substitution. So what I see here, this is an exponent, x plus 5, so all it's telling me is that this is the integral of 2 e to the 5th e to the x. I can integrate that minus this interval, and now I'm ready to go. This is just a constant, so that constant would come out front, and then I guess this part I can integrate, so that's 3 divided by 1/3. So there, I've divided by 1/3. And then this first interval just integrates to e to the x. So you would have 2 e to the 5th e to the x minus 9x to the 1/3 plus c, and then they're going to want me to rewrite this as e to the x plus 5, and that's all there is to it. There we are. They didn't put a plus c in their answer, were we not? Oh, it says do not include the constant c in your answer. Okay, good deal. Okay, well, here's one where we couldn't do what I just did in that last problem. You really would want to make a substitution in this one. And now I see what they were talking about with the substitution in the previous one. So here we want the antiderivative of minus 7 over x plus 1. So you want to integrate minus 7 over x plus 1. But you don't really know the antiderivative of something over x plus 1. You only know the antiderivative of 1 over x. But don't think of it as x, think of it as something. Right? This should be the perspective that you have. And if you separate the, don't get married to the x, it's just a number, then you can say something like, let this other symbol be that denominator, so that the differential of that symbol is just the differential of this other side. Or maybe some people are uncomfortable doing that, and they like to instead say, okay, well then du dx is 1, so that du equals dx. Then you can backtrack to your original writing, and instead of putting x plus 1, you can put u. And instead of putting dx, you can put du. And everything else would be the same. And now you have a minus 7 natural log of u. But what was u? It was x plus 1. So it's minus 7 natural log x plus 1 plus a constant. But we don't include the c in our answer, so all we do is type in this. And my hard work is paying off. Okay, you have a function here, h, and they want the antiderivative of h. So here we will do that silly substitution that they were wanting us to do before. I guess it's not that silly, but it is pretty trivial here. So we want to integrate the square root of x plus 1 over x plus 7. Okay, well, go ahead and integrate what you know, or at least rewrite it as separate integrals, because we're going to do one of them straight off and then make a substitution on the other. So this part of it I know. In other words, here's what I'm saying. So 2 integrals. Two integrals. Sorry, it's so sloppy right there. And then the first one we can do, the second one, needs the substitution. We're going to substitute the x plus 7 and get a u. We're going to integrate that. It's going to give us natural log of u. We're going to end up with natural log of x plus 7. Okay, so 1/2 plus 1, that's 3/2. Here, let me divide by 3/2. And then plus, I guess I'll write the details of my substitution. The details of my substitution are to let x plus 7 be u, so that way dx is du. Then I should be integrating 1 over u du. And I get 2/3 x to the 3/2 plus the natural log of u, but u was just x plus 7, and there we are. If I do not include the constant c in my answer, then we are done. One caveat though is one caveat here is that, and it's easily overlooked by most people, including me just now, including my professors when I was learning this. It's not just natural log of u, it's natural log absolute value of u. So in other words, the rule is that the integral of 1 over something integrates to the natural log of the absolute value of that something, because the natural log cannot accept a negative argument and still be a real number. should be no reason here to do a substitution. I don't even, I can't even go the extra mile and include extra steps to make one happen. I just flat out don't see it. It's able to be integrated straight away. I mean, you have, oh, it's a x to the minus 1/2. Well, that shouldn't affect anything. You know, it really doesn't. It's only when it's x to the minus 1. The rule, so what is our derivative, our integration rule that we have? We just have, I think, 1, and it's got kind of like 2 parts. The rule says the integral of x to the n is equal to x to the n plus 1 over n plus 1 whenever what? N is different from minus 1. If n is equal to minus 1, then the integral of x to the n is just the integral of 1 over x, which is the natural log of the absolute value of x. This must be the case down here because we know that the derivative of natural log is just 1 over x. So then you can do the derivatives of, or I'm sorry, you can do the integrals of this stuff straight away, with no problem, because those exponents are different from minus 1. So you have a minus 1/2 plus 1, that's 1/2. Here, let me divide by 1/2. And then 3/2 plus 1, that's 5/2. Now I'm going to divide by 5/2. And there's my antiderivative. Type in the answer without the constant. And there we are. Okay, on to the next topic then. Okay, now this is what people think of when you start talking about a genuine substitution. There's no way to fake it here. You're either going to do the substitution or you're going to expand that thing out all the way so that it's a sum of terms, a polynomial that you can integrate term by term. And since no one's going to do that because it's to the 6th power, then you gotta make your substitution. So you're always trying to look for which part of your integral is looking like the derivative of another part of that integral. In particular, you have an x squared here, and you have an x to the 1 over here. So I can say, just let u be all of that x squared term, then du would be 6x dx. Now I wish it said 7x dx. Well, that's easy to do. Let's just multiply both sides by 7/6. If I multiply both sides by 7/6, then the 6's will cancel, and I'll have my 7x dx like I want. 7x dx. So both of those two things make up a 7/6 du. And it's like accounting at this point. So that's gone and that's gone. Okay, here's my integral symbol. And then it's something to the 6th power. And what is that something? It's just u. So that's going to be u to the 7th over 7. But what was u? U was 3x squared minus 2. And there we are. There we are. And you can always take a derivative of that thing and make sure that it's giving you the same thing you were trying to integrate. If so, then you know that you had the right antiderivative. Okay, here's another one. It's going to be the same strategy. They want us to integrate a minus 4x times the quantity 3x squared minus 1 to the 7th power. So let u be the 3x squared minus 1, then du is 6x dx. I wish it said minus 4x dx. I could make that happen just by multiplying by minus 4 over 6. Multiply by minus 4 over 6 on both sides. Then the 6's cancel. And you've made it happen. So this would become the integral, and now instead of me putting a minus 4x dx, I can just put minus 2/3 du. And instead of putting all that stuff to the 7th power, it's just going to be u to the 7th power. So we'd be getting a minus 2/3 times 1 over 8 u to the 8th. And then simplify those constants, and you would get a minus 1/12. Don't write the u, write what u is equal to, and you are finished. Awesome. Another one of these. So the substitution will be on this part. That's what u is going to be, because the derivative of that looks like an x squared. So we want to integrate minus 2x squared times x cubed plus 6 to the 4th power. let u be the x cubed plus 6, then du is 3x squared dx. So it's got an x squared, but I wish it had that minus 2. You can make it happen. Excuse me. You can make it happen. Multiply by minus 2 over 3. Excuse me. The 3's cancel, and now minus 2/3 du is just minus 2x squared dx. So you've got all of that figured. All of that is just a minus 2/3 du, and the stuff in the middle, that's to the 4th power, that's what u was. But don't write it in terms of x just yet, just put the u. And now you can integrate. Don't need that anymore if I'm integrating, so come on now. Here's my constant, and then it's times 1/5 u to the 5th u to the 5th, but instead of writing u, I'll put x cubed plus 6. Alright, clean up that constant, you'll have minus 2 over 15 x cubed plus the quantity x cubed plus 6 to the 5th power, plus a constant. But we don't write it in our homework. And there we are. Alright, almost done with substitution. Let me tell you, substitutions can get a lot more tricky than what you've seen so far. Not a lot more, but somewhat more. They can get a little bit more tricky than what you've seen so far. So you are blessed with just these basic type of substitutions. Once again, u is going to be all of this. Then du is a minus 15x to the 4th dx. Oh, look at that. I got a minus 15x to the 4th dx. Super cool. So this will just turn out to be the integral of u to the 4th du, which is 1/5 u to the 5th plus c. And instead of putting the u and the c, they want me to just type in 1/5 times the quantity minus 3x to the 5th plus 6 to the 5th power, and that's should be the last answer of this homework. Alright, cool. See you in the next one.